All right, I just want to give you a little bit, you don't have to write this down, but I just want to give you a little bit of overview when a vertical asymptote happens and when it's a point of discontinuity. I'm just going to give you an overview and then we're going to talk about what these things mean. So we've already discussed a vertical asymptote. When does that happen? Well, if I have something like this will create a vertical asymptote. How come? Because this guy doesn't cancel out with the numerator. So I know that x cannot equal -2, and that'll be a vertical asymptote. But I just want to give you an overview. Let's say I have something like this. Okay, we have a different equation here. Do you see that if we simplified this, this would go away and we would end up with this simplified equation. When the factors cancel out, that's when we have a point of discontinuity, and we'll talk about what that looks like later. Okay, I'm going to go back to the notes. So, finding asymptotes algebraically. Asymptotes only occur if there is no common factor between the numerator and the denominator. So that's what I just showed you. So they happen when the denominator has a factor that doesn't cancel out. What is the vertical asymptote? Well, as we discussed earlier, it's whatever value makes the denominator equal to 0. So in this case, my vertical asymptote would happen at -2. Now, horizontal asymptotes, I don't want you to worry too much about why this is happening, but just kind of follow the rules. And I know I don't say that much, but that'll come out in later courses. So, horizontal asymptote, case 1. If the degree of the numerator is less than the degree of the denominator, then the line y is equal to 0 is a horizontal asymptote. So we know that the numerator here is degree 0, the denominator is degree 1, so that will be our horizontal asymptote, which is the x-axis. And that's the same if like the numerator was degree 1 and the denominator was degree 2. All it has to be is the numerator has to be a greater degree. Case 2, if the degrees are equal, then it's the coefficient of the leading terms. So we know that both numerator and denominator, in this case, are degree 1. So, coefficient of the leading term of the numerator is 2. Coefficient of the leading term of the denominator is 1. So my vertical asymptote is going to happen here at y is equal to 2. If the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. So there will be no horizontal asymptote in this case. All right. Algebraically determine the equations of the asymptotes of the graph of the function. Well, let's take a look at number 1. First thing, I am going to deal with the horizontal asymptote. Horizontal. Following my degree rules from here. And as I can see, they are equal. This is degree 2. This is degree 2. So I'm going to be following the rules of case 2. The coefficient of this term is 1. The coefficient of the leading coefficient here is 2. I think you know what I mean. So I've got my horizontal asymptotes. Now I need my vertical asymptotes. When I'm dealing with my vertical asymptotes, I'm just looking at the denominator. So I know that 2x squared minus x minus 3 is going to have to be factored. So I'm going to factor that, see if I can do it. plus minus, and I'm going to say that this is going to be 3, and this is going to be 1. 2x squared minus 2x minus 3x. Yep, got it. So my non-permissible value is going to be 3 over 2. And when I talk about asymptotes, I don't put the not equal to sign in there because it's actually an equation. But when I'm dealing with the non-permissible value, I do. This guy, x plus 1 cannot equal 0. So x cannot equal -1. All right, I'm going to let you do the next example on your own.